Welcome to the deep dive. Imagine, if you will, a kind of virtual reality tool. One that's not for games, but is actually saving massive industrial companies millions, maybe hundreds of millions of dollars. And just as importantly, keeping workers safer.
Exactly. We're talking about something called AI-powered digital twins today, and how they're really shaking up asset management in, well, one of the toughest places imaginable, the oil field.
Yeah, that's the core of what our sources were digging into. And this deep dive, it isn't just about cool tech potential. It's about, concrete results, optimization you can measure.
Right.
So our mission here is to pull out the specific tech, the how and the why. These virtual tools are basically reshaping operations, predicting failures, boosting productivity, that kind of thing.
Okay, let's unpack this right away because, digital twin, that term gets thrown around quite a bit.
Yeah.
For you listening, maybe you're catching up on this idea. What is the basic concept here?
Yeah.
In this specific context, like an offshore rig or a long pipeline. Okay, so a digital twin is essentially a live virtual mirror of a physical thing.
And
Add out in the field.
a mirror.
Yeah, think of it like a perfect simulation, but one that's constantly updated. So you have a pump working out there. The digital twin is its software replica, getting all the same data, temperature, pressure, vibration, you name it, in real time.
So it knows exactly what the real pump is doing second by second.
Exactly. It reflects its current status, its history, even where it's likely headed, operationally speaking. It's a full model.
But wait a sec. We've had computer models, like CAD files or simulations, for ages, right? That's not brand new.
Okay.
So why is adding AI, layering artificial intelligence onto this model, why is that the game changer? Why isn't just a regular model enough?
It really comes down to the sheer amount of data and how fast it's coming in.
Oh?
A modern oil field asset, just one pump maybe, could generate petabytes of sensor data every single day. A human operator or even, a standard old school algorithm that just can't keep up.
Yeah.
They can't process that flood of information fast enough to get insights now when they actually matter.
Ah, okay, that's the key difference then. The AI part is like the brain that filters the signal from all that noise.
Precisely.
It's what actually makes sense of that nonstop data flood, spotting tiny little shifts that might mean trouble down the line. It gives you that constant, informed picture of everything, from the drill bit miles underground to the valves right there on the surface. It's instant intelligence.
Yes, not looking back at logs from last week. It's about now.
Which means you shift from, uh-oh, something broke, scramble the team, to what?
To proactive management.
Yeah.
The AI is predicting what might happen next week or 10 days from now based on subtle trends.
Okay, here's where it gets really interesting, especially if you're trying to grasp the bottom line relevance of this tech. The source has laid out some huge, measurable results. Let's start with the big one operations managers hate: unplanned downtime. What's the impact there?
Well, the results are pretty stunning, actually. Because the AI gives managers those immediate insights into performance, they can see trouble coming and head it off. Avoid those big, nasty surprises.
And the number?
The research we looked at documents downtime reductions of up to 20%.
20%. Wow. That's huge. That must mean catching not just the massive failures, but the smaller stuff, too. Can you, walk us through an example? What's it preventing?
Sure. Think about a big compressor, a really critical piece of equipment. Maybe it's heading for a catastrophic failure because, I don't know, a bearing is going bad.
Okay.
In the old days, you'd probably wait until the temperature spiked way up, or you could actually hear it vibrating badly. But by then, the damage is done. You're looking at an emergency shutdown.
Right, reactive mode.
Exactly. Now, the AI twin, it's watching maybe dozens of things at once, tiny micro vibrations, subtle temperature differences between components. It might spot a minuscule weird pattern change in that bearing's vibration signature, like 5 weeks before it actually hits the failure point.
So it sees the whisper before the scream. It's not waiting for the red light. It's predicting the red light based on data a person would totally miss.
You got it.
Which leads straight into the next big win: predictive maintenance. The cost difference between fixing something on schedule versus an emergency breakdown has got to be massive.
Oh, it's exponential. Unplanned downtime means calling in emergency crews, paying rush fees for parts, losing days of production maybe. It adds up incredibly fast.
Whereas predictive means...
Predictive means the manager sees the warning from the twin weeks ahead, They can schedule a technician to go out during a planned maintenance window, maybe just replace a cheap seal or make an adjustment. It's low cost, low disruption.
Hmm.
You basically eliminate those huge emergency costs.
Okay, so that tackles downtime and repair costs. Huge savings. But the main goal in energy is always maximizing output, right?
Right.
Getting more product flowing. How does a virtual twin help with that? The sources mention, what, a 15% increase in output in some pilots? How?
Yeah, 15%. And that comes from the twin's power as a simulator. It's about optimizing the whole operation, sort of at a macro level.
How so?
Well, before digital twins, if you wanted to, say, optimize the flow rate, maybe you'd try tweaking something, increase pressure a bit, change the mix of fluids you're injecting, but then you'd have to wait maybe weeks to see what actually happened in the real world.
And hope you didn't break something by pushing too hard.
Exactly. It was slow, and it was definitely risky. With the digital twin, managers can run literally thousands of what-if scenarios in the virtual world instantly.
Ah, testing it virtually first.
Right. They can push the virtual equipment, change temperatures, pressures, valve settings, finding that perfect sweet spot that gets the maximum yield without stressing the real physical assets into the danger zone.
Okay.
Then, once they've found those validated, optimized settings, they can upload them to the real equipment with a lot of confidence. That's how they're getting those 15% production gains.
Wow. Okay, so less downtime, 20%. Predictive repairs, saving huge costs, and 15% more output. I mean, just on the money side, that's an incredibly strong case.
It really is.
But it goes beyond just efficiency in dollars, right?
Yeah.
Let's talk about the human side. Safety. These are hazardous places to work.
Absolutely. And enhancing safety is, well, arguably the most critical benefit here. Oil fields, especially things like offshore rigs or those deep, high-pressure wells, they are inherently dangerous environments.
No question.
So when the AI is constantly combing through data, looking for anomalies, tiny signs of metal fatigue, unexpected pressure drops, potential leaks, it flags risks long before they escalate, long before a person might even notice or need to physically go check.
So it reduces the need to put people in harm's way in the first place. Like, you don't need to fly a helicopter out in storm to check on a pump that's vibrating weirdly if the twin is already telling you exactly what's going on with it.
Precisely. It fundamentally changes the safety calculation. You're using virtual access to manage physical risk. And if we zoom out a bit, think about the bigger picture, the long-term health of the infrastructure itself.
You mean making the equipment last longer?
Exactly. This technology also delivers some really compelling forecasts about asset lifespan. It's not just about optimizing today's production. It's extending the working life of equipment that costs billions to put in place.
That makes sense. Less stress, fewer breakdowns. It should last longer. Is there data on that?
There is a key industry report forecasting for 2025 predicts about a 25% increase in the useful operational life of these assets, all thanks to the smarter, continuous AI-driven maintenance enabled by the twins.
25% longer life. Wow.
Yeah, and when you think about the sheer amount of capital tied up globally in energy infrastructure, stretching its life by a quarter through, better care and prediction, that's a massive win. For budgets, yes, but also for sustainability.
Absolutely huge. Okay, this is fantastic. Now, let's get a bit more specific about the tech itself, because this sounds incredibly advanced. The sources mention a specific high-profile AI integration. This isn't just basic machine learning we're talking about, is it?
No, it's devolving fast. We're seeing a convergence of really cutting-edge AI. The sources we reviewed specifically highlighted recent integrations of Grok 3 from xAI with these industrial digital twin platforms.
Grok 3. Huh. I usually associate that with, like, large language models, complex reasoning, more general AI stuff. What's an advanced model like that doing managing oil pipes and pumps? How does that specific integration change things for the oil field manager?
Well, it goes beyond just processing the structured sensor data.
Hmm.
The numbers. Temperature is X, pressure is Y. Older machine learning is already pretty good at that.
Right.
What something like Grok 3 brings is a capacity for much deeper, more complex reasoning. And critically, it can synthesize different kinds of data streams, including unstructured data.
Unstructured data, meaning what? Like text?
Exactly. Think about all the other information a facility generates every day. Maintenance logs written by technicians, geological survey reports, handwritten notes from operators on a shift change, complex fluid dynamics models. It's all potentially useful, but it's messy.
Right, not just clean numbers from a sensor.
Precisely. Grok 3 can potentially take the vibration data from pump A that's structured, Connect it with a maintenance log entry from 2 years ago saying minor seal degradation noted, that's unstructured text, and cross-reference it with a geological report predicting some slight ground subsidence in that area. That's complex modeling data.
Whoa, so it's basically building a whole story and narrative about the asset's health by reading everything available, not just staring at the dashboard numbers.
You've nailed it. And that allows the manager to run incredibly detailed, nuanced what-if scenarios that just weren't possible before. Like forecasting the likely corrosion rate of one specific section of pipeline over the next 5 years. Not just based on the current chemicals flowing through it, but also factoring in historical comments from operators about weird readings in that area years ago. It pushes predictive power towards, well, almost towards seeing the future.
That really does shift the whole thing from just keeping the lights on maintenance to true deep optimization and predicting the future life of the asset. Okay, so let's try and bring this all together. What's the big picture takeaway here?
I think it's this. We've taken the idea of a virtual copy, a static replica, and we've essentially supercharged it with advanced AI that can handle complexity. And that leads to, really, 3 transformational pillars.
Which are?
1, faster, much more accurate insights into how things are really operating. 2, vastly safer workplaces because you can detect anomalies way earlier. And 3, that projected 25% longer, more sustainable lifespan for these incredibly expensive critical assets.
So this knowledge gives you, the listener, a really solid snapshot of how top-tier AI isn't just happening in Silicon Valley labs. It's being deployed right now in tough, heavy industries that power the world, driving real-world efficiency and safety numbers that honestly seemed out of reach just a few years ago. It's operational reality today.
It really shows how scalable these AI solutions can be when you point them at complex, real-world physics problems.
Absolutely fascinating stuff. Okay, I'm going to turn it over to you for one final thought, something provocative for you listening to think about as we wrap up this deep dive.
Okay, well, given the success we've seen documented here in oil fields, the 20% less downtime, 50% more output, the big safety jumps, it really begs a question about where else this could work.
Right, transferability.
Exactly. Where else in other highly complex, maybe dangerous industrial sectors? Think about deep-sea mining, maybe nuclear power plants, large-scale drug manufacturing, even managing complex city power grids. Where else could this exact same approach, AI-powered digital twins, be applied right now to get similar results? Those 20% plus efficiency gains, those dramatic safety improvements, that feels like the immediate potential here globally.
A powerful question indeed, something really important to consider. Thank you for joining us for this deep dive. We hope you feel thoroughly well informed.